Hey, what's up guys? It's Mr. A again. Last time that we talked about logarithms in the intro to logs, we looked at this problem, which was 2 to the x equals 12, and we figured out that this was an issue because we couldn't figure out x, but thankfully someone had already invented a way for us to calculate x, and that was logarithms. And just a quick review, what we did is we looked at the fact that this is log base 2 of 12 equals x, and that's what we studied last time, is the conversion from exponential form to logarithmic form. And we also were able to put that into a calculator. So we went to, in this case, we went to the TI Inspire, and we calculated that the log base 2 of 12 ended up being like 3.58. Okay, so that was pretty easy, right? But let's take a look at another calculator that we've used at times, which is the TI-84. And if we try to do this problem here in this calculator, we look for the log button, and it's right here beside to the left of the 7. So we hit log, and this is different than what we saw with the Inspire, right? Because this just went straight to the number, like the number that we would put in there, and it doesn't list a base. So it's a little problematic because we kind of need that base in there, right? And if we don't have that base, then that's probably a big issue. So we got to figure out what's going on with this calculator and why it's not putting the base in. And that's what we're going to be doing today, is figuring out a way that we can take this problem right here, log base 2 of 12, and figuring out a way that we can make this calculator friendly, because the Inspire is probably the only calculator that I've seen, or at least the most popular calculator that I've seen that can insert the base in there for you. And the other TI calculators or some other scientific ones don't allow you to do that. So we're going to be checking out Learning Target 9 today. And I know that I have skipped 8, and I'll go back to that. But it says I can apply the change of base formula. And there's a little supplemental practice for you if you need that. So what we're going to do is we're going to look at our number system. Okay, and we're going to look at a cool way to take this and transfer it into like a little bit more calculator friendly form. So let's take this. What we're going to do is we're going to apply the change of base formula. And the change of base formula allows me to write it, this expression, so that it doesn't have base 2, but it has the same base as the other calculator. And I know you're probably wondering, what is the base of the other calculator? Well, let's take a look at this. The change of base formula would say that this is log of 12 divided by log of 2. Now again, this log doesn't have a base either, just like the calculator. And I remember doing this in high school. I always used to have problems figuring out what number is in the numerator, what number's in the denominator. And just sort of look at this from the aspect of this number 12 is already bigger than the number 2. So it's almost like if you just drew that line, you can see that the 12 is higher than the 2. So that's the one that goes in the numerator. And I'll give a little bit more detailed explanation of that, of why this works, in another section. But for now, we're just going to learn this property. Okay? And let's take a look now at what is missing right here. Like, where is that base, or what is that base? So we're going to take a look at a number. I drew some place values out here, and I'll put a decimal point here. And let's just look at the number 724. Okay? Now, if these were place values, to the left of the decimal, this would be the ones place. This is the tens place, this is the hundreds place, and this is the thousands place. Okay? And if you notice, all these are powers of 10. This is 10 to the third, that's 10 squared, that's 10 to the first, and here's 10 to the 0 power. And even the decimals, that's 10 to the, this is the tenths place. Sorry about the da-da-da there. I was stuttering a little bit. So 10 to the -1 power, 10 to the -2 power for the tenths and hundredths place. So we say that our number system is base 10 because every place value represents how many tens or how many of each power of 10 that we have there. So for example, 724, the number 7 would represent that I have 7 hundreds, the number 2 would represent I have 2 tens, and the number 4 would represent I have 4 ones, or 4 of 10 to the 0 power. So when I look at this change of base formula and I see log without a base, it's actually understood to be base 10. Okay, and we just don't write it there. And it's kind of like the same thing as looking at the variable x and asking what's the exponent of that variable. Well, even though it's not written, it's understood that the exponent is 1. And if I ask you what the coefficient is of that, well, it's not written, but it's understood that the coefficient is 1. And the reason we don't write them is because it just seems silly to run around saying, instead of just saying x, oh, I have 1 times x to the first power over 1. You know, that's overkill. So we don't, say all those things about the exponent and the coefficient being 1, just like if it's a regular logarithm, we just say it's log base 10. Okay? And if it's log base 10, whenever you see log of some number like log 12, if it's base 10, that is what's called the common logarithm. By the way, I've got to apologize for my handwriting. For some reason, this video editing software does not play well with the smartboard. My handwriting is actually not that sloppy. At least I don't think. If you're a student looking at this, you might disagree. But I think I write better than that, I'm pretty sure. So what we're going to do is we're going to take this change of base formula and we're going to apply that in the other calculator. Now remember, in the Inspire, I got 3.58496. So if I take this expression and put it in the other calculator, it'll be log 12. And you be careful with your parentheses. We're going to close the parentheses up and divide by log 2, close parentheses again. And yeah, we get the same exact thing as the other calculator. This calculator just has a setting to go with a few more decimals, or a few more decimal places. So we get the same thing. So that's a good thing. We want the same answer. So let's try that again. We're going to apply change of base with 5 to the x equals 673. So if I put this into log form, it would be log base 5 of 673 is equal to x. And I can put that in the Inspire, log base 5 of 673, and I get 4.04597. Again, that is the exponent I raise 5 to get 673, or the power I raise 5 to get 673. So now I'll try it in the other calculator, but remember, I've got a problem here because it doesn't have the capability of putting in a base 5. So I'm going to go back and let's apply the change of base formula. So it's going to be log base 10 over log base 10. We just have to figure out what number to put and where. And it's going to be 673 over 5. And another way that you could think of this is the base number, so base bottom, right? Base goes on bottom, or base bottom. And let's go ahead and put log 673 over log 5 in the calculator, see what we get. We'll get log 673, close that parentheses, divided by log 5, and hit enter. And yeah, that's the same answer that we got with the Inspire. So that's the change of base formula. It comes in pretty handy if you want to use a calculator that does not allow you to specify the base. If you have a TI-84